So far we have covered the hooks like use context and use ref and use state and use effect. In the series we'll be covering the next hook called use callback. Then we'll be covering use memo too. So basically when it comes to use callback and use memo, these hooks are something for these hooks are majorly used for optimizing the React application. Okay. One thing, so far, you have seen something like state hook. Use state is used to bind the state. Then use effect is used to make side effects, call the side effects, and use ref is used to have a current value without re-rendering. And use context is used to consume the value which is provided with the create context. So these are the things which you have seen. Now you will be seeing another major hook called use callback, use memo, which you will be working in your day-to-day life and day-to-day dev life. Okay. So before understanding the use callback in React, you need to understand the concept of memoization. Okay. So memoization. So memoization is a technique used in computer science to speed up the execution of anything. It's not only something like function, anything it can be. So memoization is nothing but it's a technique to speed up the execution of function by catching it results. Caching. What is this caching? What do you mean? You need to understand the word caching. So what do you mean by caching actually? So it is something that you take an example something you have prepared one function. Okay. Now look at this concept. What I'm saying, just observe the concept which I'm saying you. Okay, I have created a function called sum. Okay, let us think we have a function called sum. Okay, now a comma b. Okay, inside you have an a comma b. Then what you are doing something like return a plus b, return a plus b. Now this is a reusable function that can be used across your application, right? So it's okay. Now you have learned some good knowledge, something like that function is a reusable logic that can be used across the application. But have you ever thought of something that if you place this inside a component, that component gets rendered. I had already showed you how the component is being rendered. So if the component gets rendered for each and every render, a new function would be creating. A new function would be creating again. So for the first render, a new function would be creating. So this is a base concept which you need to understand so that you can better understand what is the optimization we are targeting. Okay. Now, so for second render, again a sum function is being created. So it would be an incremental. It would be an incremental, something like the renders will be going on. The more the renders would be happening, re-rendering, more the re-rendering happening, more the functions would be for each and every render, the function would be creating once again. Once again. So this is the base concept you need to understand. For each and every render, the function, if you write any function inside a component, if that component got re-rendered, the function will be getting new, creating, will be getting created newly. Okay. So that you need to understand. Okay. So getting newly created means what it means. So it means that for first render, the function would hold a value of address, something like fun 100. Okay. If for the first render, if the function created a function would hold the address value of function 100, and in the second render it would be something like fun 200. It will be creating new one, and it will be referring the new function now. Okay, in the series it will be creating more and more functions on each and every render. And you could see something that for first render, if you compare the sum with second render, it would be definitely new, because definitely the when you compare this first render function with the second render function, you'll see something like a different memory locations. Because of this different memory locations, it treat it as a it as a different. But even though the content inside the logic inside the function remain the same, but for each and every render, the function is getting recreated again and again. So why do we need to do that? Why do we need that one actually? So we need to understand something that why when we need to create a function again and again, when we need to create a function. So how do you optimize the creating of function on each render? So remember something that on each render, a new function is being created. So to control the creation of functions, we would be using a technique called memoization. Okay, we'll be using a technique called memoization. So memoization is nothing but it return if there is no change, if there is no change in the function, if there is no change in the function, it means that for example, you could understand something that we will be having one dependency here. Dependency, I had already explained you about the dependency. Use effect, we have been explaining you about the dependency arrays. What do you mean by dependency? Dependency is something that if the dependency got changed, again the logic inside use effect will be running. The same thing, the same logic would be applicable here also. Here this function would be against the dependency. If that dependency got changed, then again this function would be recreated. If the dependency not changed, the function would be the function which is there, the function is cached in the previous render. That cached function would be returning. Okay, now we'll understand. Now we have learned, we have seen the theory. I will be showing this with the help of example also. But basically, it's all about memoization. Is nothing but it's a technique used to cache the function. Cache the function, it what it means. So you will be caching the function, and if there is no dependency change, the cache function is returned instead of creating new one. That's only that's only main concept which you need to understand while dealing with use callback. Okay, before this concept, I want to make you understand one more concept in memoization. React.memo. I want to make you understand what is React.memo. I'll say you this one. I'll say you in this one in coming lecture, coming sessions. But before that, for now, I'll be giving you glance what it is actually doing. Okay, what it will actually do. Okay, let's go ahead and see this. React Memo is nothing but it works on the same principle. It works on the same principle. It works on the same principle. Same principle like it works on the same principle. So a component, a component, a component, a component, a component like child, a component like child, a child, or else you can write something like a child component, a child component will get re-rendered only when it props got changed. Only when it prop got changed. I'll show you what exactly I'm speaking when props get changed. Okay. Okay. Now what you need to understand, because before going into understanding the core concept. So here I wrote some sentence. What it mean? I'm saying something that React.memo is an memory memorization technique. It works on the same principle. It works on the principle. Maybe we can write as it works on the principle. The child component will get rendered only when it props get changed. It means that we have two components. One component is parent component. Okay, parent component. We have a two component. One component is parent component. If let us assume that inside this parent component, you have something called a state variable. Let's assume state variable is count. Okay, count. You have a count state variable. Now think of that. Now think of this count variable. This count variable is being sent for child component. For whom it is sending? The count component is being present is present inside the parent component, but it is sent to child component. How it is? How we can share it? We can share it as a prop. Okay, you can send it as a prop. Okay, now you're sending the count variable. Now what is the issue? So when see, actually you can memorize this component. You can control the re-renders of the child component. Okay, now along with count, I'll be having set count. Okay, set count. So what set count will do? Set count will whenever there is a count, whenever we need to update the count, the set count will trigger a re-render, right? The set count, what the setter function will do? Update function will trigger a re-render. If the parent component is re-rendered, the child component is present inside the parent component. Now what happens? The parent, along with the parent component, the child component will also be re-rendered. So this is the issue. So now what happens? Now what happens means when if there is no prop, if there is something like along with this, if we have something called age, okay, age and age, set age. Now see, actually parent component has inside child component inside, but it is taking count variable. Okay, it is taking prop as a count variable. Actually, age, you have age in your parent component and set age in your parent component. Now think of set age, what it will do. If there is a function called to update the age, then what it does? If we click on that function, the function get triggered and set age will be called. Set age will mutate the value of age, and it also re-render the component. Now again, the component got re-rendered. So parent component has age variable. That's why it's re-rendering. But what is the scope of re-rendering the child component? Because child component doesn't need this age variable. Now what happens? Unnecessarily, a re-render would be triggered for child also. That is an unnecessary re-render. That is an unnecessary re-render. So to prevent this type of re-renders and make it as optimized, we need to use some techniques. One such technique is known as a React.memo. What it actually do means, React, when you wrap a React when you wrap a component with the memo, then what it does means, it will check for the prop. If prop got changed, then only this component will be getting re-rendered. If prop doesn't got changed, prop or state variable, anything, if it doesn't get changed, then it won't even re-render. Now I'll be showing that in example. Okay. Once after understanding the React memo, you can better understand what is use callback and how use callback would be working. Okay. So for this, I'll try to go and open. I'll try to go and open VS Code. VS Code. Now let's see. I'm in different project. Okay, demo hooks. So right now, so far we have covered use ref, use context, and use state, and also use effect inside this only. Now I'm trying to create new project named use callback. Maybe let's start with use callback. Okay, npm create. This is as usual white at the rate of list. Okay, this is as usual. Okay, now it will ask for creating of yes. Just give dot. No, dot. We need to create a use callback, use callback project. Then this should be the use callback package name. Then it should be a React. Then it should be a JavaScript. Now you can go to CD. You can see the instructions. Based on instructions, you can go ahead and you can create. Now try to run npm install. It will install all the packages which is necessary to run this project. Okay. Before it gets installed, what we will be doing means we'll be going here and we'll just clean up the JSX file before everything runs. Okay, now inside this, what I don't want this all those things. This div I don't want. I'll just remove this div. Okay, this is not required, and we don't want this. What we don't want this stuff. Okay, okay. Now what happens? Now I have only let it get complete. Let it complete the things faster so that we can move ahead. You'll see the magic how the re-render is actually happening and how it is controlling, how we will be controlling the components and how you will be controlling the recreation of functions and how you will be controlling the values, function returning values. So how you utilize those concepts to make to make your application stable. So your application should not be re-rendered unnecessarily, or your application should not be something like bloated with all the code, with all the optimization not needed. And you need to make your code something that the re-renders is one of the biggest concerns, which is most predominantly found in everyone's code. I could say that there will be definitely an optimization scope for each and every project, but we need to identify the chance of optimizations. Okay, then only we can go ahead with our logic with for a stable and bug free production code. Okay, now let's wait for 1 more minute to complete this process. So now we are just trying to understand React.memo, what React.memo is doing. I will be explaining after this one. I will be explaining that part again, again one more time when we are dealing with advanced concept. Now, for now, if to understand the use callback and to understand the use memo, it is necessary to understand React.memo first. Then only done better in a better way. Okay. Why this is taking stuff time? Okay, now it completed. Now I'll run npm run dev. Okay, run npm run dev, and it will run a server. Okay, it will run a server and 5173. Okay, now I'll open localhost 5173. Okay. Oh, 73, fine. That works out. Now what I'll be doing means I have a count variable. Now see, now I have another variable called age. Let's think how we have another variable called set age. Okay, it has something called set age. Okay, set age. Okay. Now what I'll be doing is use state. It might be something like 30. Okay. Let's think it's an initial value as 30. Now you have something called inside this one you have let's like you have something called child component. You have on the child component. Okay, child.jsx. Okay, child component where this is called inside the where it will be called inside the app function. Okay, now I'll be calling child. Just simply I am calling child. Now see, to test whether our code is working or not, we'll be seeing here and we'll write something child. You need to be able to see the child in your C. Now you are able to see the child. Okay, now our code is working. Now our component is also exported correctly. Now what's the thing is, now I'm going to send one prop here. See, one prop that is count. I'm sending for child component count. I'm sending the value count for child component, and this child component will receive it. Okay, it will receive count. Okay, it will receive count, and I'm showing this count here. Okay, I'm showing this count here. Okay, to show the count we need to just embed inside parenthesis. Okay, now done. Now my work is almost complete. Now if you see here, you'll be seeing count. Okay, now I'll make it as more legitimate, more I mean more visually appearance. For that, I'll be visually appealing. For that, I'll make it as H1. That would be better. Okay. Now, okay. Now done. My work is done. Now I'll be like count 0. Right. Correct. Now what happens? Now see, this child is utilizing the prop which is from app component. You have a prop inside. You have a prop here. That set count function will set the value, and you here child is receiving the count, and it is actually doing something. Actually, it is rendering the content. Now what happens? Now here along this child, I have two buttons defined. Okay, two buttons defined. One button is to increment the count. One button, another button. You have another button on click, on click, on click set age. Okay, now see, now what happens? One button is to increment the count. One button is to increment the count. And another button is used to increment the age. Now, if you see the output, you'll see two things. Okay. Now, just go, I'll open the console window. Now, what happens? Let's see. Now, you are seeing something like in console window. Now, you'll be you can go here, and what you're doing now, see something like I will be writing here inside this one. I will be writing console.log of child render. Child is rendering. Child comp is rendering. Child comp is rendering. Child comp render. Now what happens means you can go here and just remove the breakpoints. We don't want these breakpoints to understand this concept. We can directly go here and just remove this one and just refresh. Now you see, this is for first render. Now what, when I try to click on increment count, okay, now observe what is happening. Increment count, what happened? I have React strict mode. Let me remove that strict mode. Okay, now I'm almost done with. I'm just you just observe the things. You just observe the things. Okay. Now initially child comp rendered. Okay. Now this is fine. When I click on increment count. Okay, increment count. The child comp is rendering. That means here the component which you are passing, the child component which you have created, you are calling inside this component inside the app.jsx as you are clicking, as you are calling set count. What happens? The whole component will get re-rendered. Due to that, you have child component inside the parent component. That is the reason child component is also rendering. Now see. So, and one more thing, you are passing the count variable as a prop to child. That means the child should have the updated count every time. So it is correct when you click on click and set the count, a count is updating, and that updated count is passing to child. That's fine. That's fine. This looks very good, very pretty much good actually, because you are updating the count, and that updated count need to be rendered, passed to child, and that is the way it is re-rendering re-rendering. That's picture perfect. That's very good, fine. That is how it needs to behave. Now you see something like, now I click on increment age. Again, why it's getting changed? See, you're seeing number two. If you click on increment age, so do this component require anywhere do you see anywhere age is utilized here? You not even see age is utilized here. It utilizes only count variable. But why? When you trigger something, see you're triggering this, but on this button you're triggering the on click event. So what happened when you click when you trigger a on click? What happens? It triggers the set age. Set age is something that it actually sets the age. Along with that, it re-renders the parent component. Once it re-renders the parent component, as child component is also present inside the parent component, the child component will also get a re-rendered. Will also get re-rendered. That is the reason. Even though if you see the increment age, the child component is being re-rendered. Re-rendered. Child component is being re-rendered. So this is not the behavior. This is not correct behavior. Why this is not the correct behavior? Because this particularly age is utilized inside. Age is utilized inside the parent component. Okay, for example, if you see something like, for example, let's think of like h1, you have something called age. Okay, now age is being utilized on the on parent component. So now what happens if you try to do something like increment age? So why it's being, this parent component is okay, inside parent component it needs to show the update account. That is why it's rendering. Why the child component is rendering? Actually it should not. Actually it should not. So we need to control the child component render. So to control the child component render, we have a concept called React.memo. React.memo. So what actually React.memo will do, I'll show you. So we need to just wrap this component where we need to just wrap this component with React.memo. React.memo. That's it. That's it. You are nowhere need to do anything more than this one. You are nowhere need to do anything more than this one. Okay. So you need to wrap this component. We need to wrap this component, and what you need to do is you need to wrap this component with React memo. Just you don't want to do something anything. Just see just what I did. I just created this component, right? I'll take all this logic. I just write React.memo. I'll create a memo. Then for this one, I pass this as a argument. Okay. Now what happened? Now simple in a simpler terms, I just wrapped up this this count component with React.memo. Now if you go here and see, now I'll remove this one. Now when I see here, now child component, now what happened? Increment count. I just clicked on increment count. Okay, child component rendered, because count variable is passed as a dependency for child component. Yeah, that's fine. That's fine. This is the expected behavior, because child component is expecting the prop count. Okay, now next thing what? When you try to click on age, see, now age is incrementing. Now are you seeing any child component render? No, see, it's 19. I'm clicking age. So what it happened? So what is the base concept behind this one? The base concept behind this one is something. So React.memo, how this React.memo will work means it observes the count, it observes the prop which is being sent to. Okay, it observes the value which is sent as a prop. Okay, Okay, see what it does. It observes the prop every time. It observes the prop every time, and whenever the prop value got changed, again it will re-render the component. Again it will re-render the component. That is the reason why you are seeing something. Why you are seeing something like a value. When you click, when you go here, when an increment count is happening. Now the count is 19. Now count got changed to 20. That is the reason why the child component is being rendered. And when you have something where you are not passing age variable as a as a prop to child component anymore. So that is the reason if you click on age, you would not be able to see the update or re-render on child component. This is one such beauty of React.memo that works on props comparison, and it triggers the re-render and it controls the re-render based on the props by observing the props. Okay, now you understood the concept of React.memo. Now let's jump back to the concept of use callback. Okay, now what actually you need to understand. You understood the concept of React.memo. Now simply I'll just make you understand this use callback. So in simpler terms, what actually use callback means, it's also a memoization technique. It's also a memoization technique. Memoization is something that if there is any change in dependency, then the callback, inside the callback, what is the logic present, that logic should be triggered. Okay, so in simpler words, if you have any logic inside the use callback, that logic would be triggered when there is only dependency change. So, and use callback is something that inside in React, what is actually use callback? Use callback is nothing but it caches the function definition. See, it caches the function definition between the renders. I'm stressing the point again. It caches the function definition. It doesn't call the function. Calling function is different, and caching the function definition, function defining is different, and calling the function is different. Function call is different and function definition is different. Okay, just observe the what observe the core difference. If you are well versed with JavaScript functions, you can easily understand this one. Function sum, you have something called function sum. So this is known as a definition. Okay, this is known as a definition. This is known as a definition. Function sum, and this is known as a definition. Okay, now to run this function, to run the logic inside the function, so you have something called return a plus b. Let's think of return a plus b. Okay, you have the function, you have the logic inside this one. Now what happens? Now when you try to, if you want the value from this function, you need to just call the function. Okay, this is known as function calling. This is known as function calling. This is the above thing. The above thing which you are seeing here is known as function definition. Okay, this is function definition. Okay, now what is the core concept behind why I'm saying this one? Now see, as usual, to understand the use callback and its efficiency and what it does, you need to go through. You need to understand this function. Use callback is something that which works on the function definition, not function calling. Okay, not function calling. It works on the function definition. What actually it does means, now see, if you have this function, inside our main function, inside our main component. Now let's think as our main component is function app. Okay, function app, this is our main component. Now what happens means, now you have this one inside, this main component. Okay, now this is inside the main component. Okay, now what happens? Now what actually, when you see this one, this is inside the main component. So now function is inside the main component. Now what happens if there is any re-render happening? Think of like if there is any re-render happening for this app. So now think of like app is getting re-rendered for the first time. App is re-rendered for the first time. A new function is created. See, as this works on definition, as use as this works on definition, in JavaScript, what is the way of creating a new function? On every re-render, first render, a new function is created. Okay, a new function is created, and it points to memory location, something like hash fun 100. Let's think as fun 100. Okay. Now on again a re-render happened. Again some due to some click to action or something. Yeah, a re-render again happened. A re-render again happened. Render. Okay. A new function a re-render happen and a new function is created again. Again, a function is created with a different location. Now you have two functions. For two renders, you have two functions created. Okay. Now why this need to be created every time? Now think of that. Why this need to be created every time? If you have anything, if this is the same function, this is the between the renders, it is the same function. But what if the case when it needs to recreate it, when it actually need to recreate it again? You need to control the recreation of functions for every render. So it should not for every render the function should not be able to create again and again if there's no change required. Okay, when it actually requires the creation, then only it needs to be created. Unless it is not required, we should not create the function again. But on every render, what's happening? The function is being created, but the function is being created. I will show you. I will show you the answer. I will show you the thing. I will show you the things actually how it's working. Now actually use callback. Use callback is one such hook which is utilized utilized to memorize the function. Memorize the function definition. Function definition. Remember function definition. Function definition. It's not function calling. Okay. It's a function. It's a performance optimization technique. It is a performance optimization technique. It's a performance optimization technique that prevents function recreation every time. Function recreation every time. Okay, every render. Okay, it avoids the creation of function on every render. Okay, it simply it cache the function. It simply what it does, it simply cache the function cache the function and return it and return it and return it when there is no dependency change. Okay, now how do you define how do you work with use callback? I'll say you that thing. Okay, now you understood, right? What is the core concept behind the use callback? To avoid the creation of functions again and again. Okay, creation of functions. Remember the word creation of functions. Okay, now see what happens. I'll just go back to here and I'll try to explain you. I have something called count and age. Okay, count and age. Okay, now I'm showing this age here and I'm showing this count here. Okay, that's fine. Then what happens? On click, I'm setting the count here. On click, I'm setting the age here. Now see what happens. Here instead of this one, I will be doing something like control X, handle increment. Okay, handle increment. I just call this function. I will define this function here. Okay, I'll define this function here, handle increment. Okay, handle increment. Okay, now what happens? Now see, this is a function that actually sets the value set count value to count plus one. Okay, that sets the value count plus one. Okay, now this is fine, right? Now this is fine. This is the function which is responsible for updating the count. Okay, now let's see this one. Let's see whether it's working or not. Now you'll see. I'll refresh the page and now you'll see increment count. It's incrementing. It's working as expected. As expected. Okay, now this is fine. We have created we have just extracted the logic of setting the count from to a function handler. Okay, now what happened? I will just write previous in useref we created something like, when explaining useref I just created something like ref array and I compared by array elements. Right now I shall not do this one. I'll be doing some in different way. Now I'll be doing something in a different way, something like to observe this change. Okay, I'll just write use effect inside this one. I'll just pass an array. So this is use effect which we know. Okay, inside this use effect I'll write a logic something like console.log function got created. Function got created. Okay, function got created. Okay, now in this dependency I will pass this complete function. I will pass this complete function. Now understand the thing. Now you can understand something called Okay. Okay, no problem, no problem. This is common error, no problem. Now see, common warning. We need to optimize our code. Okay, just for demonstration purpose, I'm doing this one. Inside this use effect, what I'm doing, I wrote a logic to console. It will print function got created. How when this will run, on initial render it will run, and also whenever this handle increment got changed, whenever this handle increment got changed, it will run the code inside the use effect. Now see. Now I'll go here. I just don't want, this is okay, this is fine, no problem. Now see, how many times this increment count is being, how many times this increment this function is being created. Just observe this one. I'll go here and I'll try to refresh the page. Okay, refresh the page. Now see, this is the initial render. On initial render, this is quite common. The function will be got created because this is the initial render. Okay, now see, on increment count, I am seeing that function got created. Function got created. Okay, let me remove this one. It will make you some hard to understand this one. I'll just remove this console which is present inside the child for now, for better understanding. Okay. Now see, now what happened? The function got created and first initial render. Now I click on increment count. Function got created. Then again, on every count, what happening? On count update. So the function is being created again and again. Okay. The function is being created again and again, and the function is being created again and again. That's why, right? That's why, right? That is the reason why you are seeing this function got created log inside the console. On console, you're seeing something like 16 times it got printed. That means that 16 times this handle increment function got changed. That you are understanding, right? 16 times it is being recreated. This function is being recreated for 15 times. Now see what happens. Now again now again now what happened? This is fine. Function got created. Increment count function got created. Number two. This is the actual behavior. Now see, when I click on increment age, now also the function is getting created. Why? Increment age function is getting created. Increment age function is getting created. So actually, what this function is doing, it is setting the count. But why do this function will get created even when you click this increment age button? It is not right. It is not required, right? It is not required. This function need not to be created for this action which you are performing on increment age button. It should not create the function. It should not create the function, but it is creating and this log is generating. So this is something that not unexpected. So if you have something called some 10 buttons inside your component, it will make your application dead slow. When your application will goes to higher level, then what it happens? Your something your compo your compo you completely your application will become bloated. Then in terms of that, what you need to do, you need to control this creation of function. You need to 100% control this function creation. You need to control this function creation. So to control the creation of this function, we bring a concept called use callback. Okay, we brought a concept called use callback. So what you can do actually, what actually you can do, so I'll explain you. Just do something like, you just take out this function, complete function, cut it. Just write utilize use callback, and just have this use callback and use callback. And before this, I want to explain you the use callback syntax. So use callback is something that use callback accepts two things. One is function definition, and another thing is dependencies. Okay, you understand this one, right? Use callback accept two parameters. One is function and another thing is dependencies. And particularly these dependencies can be n number, and it is written inside the array, something like array of dependencies. Okay, now remember, now what I'm doing, I just created a use callback. For this use callback, I'll pass the function. Along this passing the function, I'll be adding one more dependency. That dependency is something like count. I just add the count dependency as count. Now see what happened. Now see when you go here, when you go here, now what happened? I'll just run this one. Function got created. Now on increment count, the function got created. Now if you see this increment age, now the age is incrementing, but the function is not being created. How this is happening actually? So this is what expected. So use callback is doing something which is which it controls the creation of function and again. What it does, it stops creating function for unusual renders. Actually, the basic concept is that when you trigger any set action, the function will get re-rendered, and on each and every render, the function would be creating. But use callback, what it does, it stopped actual flow. What is the actual flow? On first render, it needs to first render it needs to create function. Okay, then second render, then again second render, it needs to create function. Actually, this should be happening first. Create function would be happening at something like fun 100 at memory location, and second one would be something like fun at 200. But what actually you're doing, you're simply doing something that with the help of use callback, you're not creating the same not creating the second function for second render for second render. What it does, it returns the same function. It returns the same function which is cached. So that is the promise of use callback. That is the power of use callback. Okay, that is the power of use callback. You need to understand how use callback is controlling the function creations. So this is how you can. I'll show you again. Okay, I'll just remove here. Then see, function got created. Now what happened? Now what happened? On increment count, you are seeing the function got created, but on increment age, it's not even render. It's not creating. Okay, it's not creating. Now see to better understand what I'll be doing something like. So I have so this is one thing you need to understand. Okay, so I believe you understand what actually use callback is doing. Okay, now let me explain you another same example that would help you to understand more. When you pass this handle increment to child component, now you're passing count variable. That's very much pretty much clear. What happened if you pass this function to child component? Now I will explain you that. Okay, so what I have saying, so now we, with the help of child component, for this child component, I will now pass handle increment we instead of count. Okay, now see, now I'll just pass this handle increment as a prop here, and as in the case, this handle increment should be something like it needs to be received by handle increment. Okay, this prop should need to be received by child component. Okay, that's fine. Now what I actually doing is, I'll just move this one to this h1 to I'll move this h1 to app.jsx. So I'm just intentionally moving. It's not required to move, but to demonstrate the purpose, demonstrate the thing, I'm just moving it. Okay. So now you have count variable displayed here and age variable displayed here, and for the button button which is handling the handle increment. Now I'll move this to child component. Okay, child component. I move this to child component. I just remove the console log. Okay, now this works 100%. Now see what I wrote. I don't want to see this one again. This use effect, I'll just comment it out. Now what I did, I have did now this one also. First, I don't want to show you the solution. I want to show you I show you the problem first. Okay, const 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 handle increment. Why this a is not working? Okay, done. So this is a normal function. Now this is a normal function, and this function is passed as a prop to child component. Okay. Now you have child component which receives the prop handle increment function. That in turns, what it does, it sets the count value. Now inside this child JSX, you are receiving the handle increment, and you are passing it to on click. Okay, on click increment code. Now you'll go and see here. Okay. Now I'll just remove this one. Now what happened? Just observe this one. Now, actually, what you are doing, you printed child comp rendered, and also something called, and also you can see you can dependency. Wait a second. So I got some call. Hello. I'm in session. Okay, 5 minutes call just now. Okay, I'm back. In app.jsx, you have something called const handle increment. Okay, and this has function got created. Okay, now done. Now done. What happens? Now see, I'm passing handle increment as a prop to child component. This child component will receive, and whenever I trigger the on click event on button, this handle increment will be called, and in turn it will it will go here and it will trigger the handle increment, and it will set the count, and an app would make the parent component to re-render, and as child component is present here, the child component would also get re-rendered. Now observe this one. Now observe this one. What happens now when you go here, and increment before its initialization? What happened? uh, okay, I need to have it as before, not above, because this is an arrow function, right? Now you are seeing something like count and age. Now what happened? Now see, child comp rendered, I mean child component is rendered, and also function got created. Okay, now observe this one. When you click on increment count, you are seeing something like child comp rendered and function got rendered. So actually there is increment count is present inside the child component. Now see, increment count is present in the child component. You triggered a click event from child component, and the app receives that one, and it got created. It created the function, and what it does after creating the function, what it does, it updates the value, and it updates the value, and it again. Okay, now when you go here and see, when you click again increment count, again it's creating, state component is creating, and also function got created. Now I shall remove this one. Now see, if you what happens, let's think of like what happens if you click on increment edge. Now see, increment edge is again creating. When you click on increment edge, the function is getting created, and a child component is also getting created. This is an unusual behavior, right? This is an unusual behavior. Why this is, even though you just pass it the, you have React.memo. You have already React.memo. But still what you're seeing. But you big why even though if you got React.memo, what it compares the props. If prop got changed, then only this child component is rendered. So now if you're seeing that rendering, child component is rendering, now you can assume something that this handling increment is completely is not the same. This handling increment is not the same every time. Okay, to for this handling. Now you can understand something, right? Inside component, you are using React.memo. Still, that React.memo is not working as expected. Why it's not working as expected? Actually, React.memo, what it does, it compares the props. It compares the props, and based on the props value, props watch only, child component rendering would be happening. Child component rendering would be happening. So now you are seeing for every, even you click on increment edge, or even you click on even increment count, even you click on increment edge, you are seeing the child components being rendered. But actually what it should, what when it should it re-rendered, when the handle increment is being changed, then only it needs to change. Now go back to app.jsx, and you see handle increment is passed as a prop to child. Now even you clicked on button set count, and even you increment count, or and even you clicked on the button increment edge, what it's actually doing, it's actually recreating the function. And this function recreation is sent to sent for child, and it sees for each and every render what it sees. Actually, I'll explain you that. For the first render, for the render one, you are not using callback here. For render one, as you are not using callback here for render one, So in this handle increment for the first time, for the render first time, what it will does, the increment handle increment count would be storing at location fun 100. Okay, fun 100 for the second render. For the second render, as you are not using use callback, what it does, the re-render would trigger the recreation of this function. Okay, for function 100, for the first render you will be seeing something, a function created at different location. For second render you will be seeing function created at the different location. Now you are passing this as a prop to child. What happens here? So a child component sees this handle increment for every render as different, because first render it is 100, second render it is storing it to location 200. So in turn, what it does, and here React.memo, what it does, React.memo compares the props, right? For the first time the prop is at prop which you sent React, and handle increment function is from function hash 100. For the second time it is from function hash 200. Even though the function logic inside that is remains same, but still you are seeing a different function. That is the reason you are seeing the child component, and React memo is working as expected. But this is because handle increment function is creating and again to avoid such type of behaviors. To avoid such type of behaviors, when you need to pass a function from parent component to child component, you need to definitely use callback. You need to use callback. When you use this use callback, what happens? Let's see. When you use this use callback, now you'll go here and just refresh the page. Refresh the page. Now see this initial render, that's okay. Increment count, function child component function got created. Child component function got created because this is the actual expected behavior. Now when I click on increment age, now see increment age is incrementing. Where is re-render? The function, the child component is not re-rendering, and function is not at all creating again. You're seeing something, right? Increment age is restricted to now parent component only. Child component is not even rendering, and function is not even getting created. So this is power of use callback. Now what you did with the help of use callback, you just control the creation of functions and also renders of re-rendering of child component. You achieve two things. What you achieved? First thing is you control the function creation, and second thing is you control the re-renders of a child component. So that is the beauty of use callback. Okay, so you remember the thing, use callback will work on the concept called function definition. It doesn't work on the function called function call. Okay, now understand something, that function definition is something. Function definition use callback returns the memoized cached function. Memoized function. Use callback is used to return the memoized function. What do you mean by memoized function? Now it simply, actually, if there is any dependency change, then it will recreate the function. If there is no dependency change, it will return it will return the existing function which was created earlier. Okay, it will return the function which was created earlier. That is known as the cache function or memoized function. I think now you are clear with use callback. So this is actually the concept of use callback. So I have explained something, all the things which I said in orally in the document. Just go to the document and just follow the document. You can easily understand the document, and I have given a different example in document. You can either follow that one, and you can also see the video, and you can follow the example of this one. Okay, so that's how the use callback is working. Now let's go to another optimization technique called use memo is something very much similar to use callback, but use memo will be working on memoized value. It's actually what use callback is doing. Use callback returns the memoized function, but now use memo returns the memoized value. So what is this function, what is this value? I will say you, just we'll discuss that in a while. Okay, similar to the concept of use callback, we have a concept of use memo. So what is actually difference between use memo and use callback? So it's sort of like a slight difference. It doesn't have much difference. See, I'll try to explain you the React.memo. Okay, use memo. So now you are seeing something like function sum. Okay, this is function sum. You are something like passing a comma b. Then what you are doing? You are simply you are returning return a plus b. Okay, you write something like return a plus b. That's fine. That's very good. That's very fine. That you have created one function. We have created one function. named sum, then you have just made something that changes called a function created function created with some name sum, and it returns a plus b. That's fine. Now what actually happened? So here this is known as a, as I said before, the what it is actually, this is something like this is something like function definition. Okay, function definition. Okay, function definition. Now when you see something like function, now to utilize that function, to get the value from this function, what you will be doing, you'll be calling this function, and you'll get a value here. For example, you'll be assigning something like const final result, final result equal to sum. Okay, what actually you're doing? You are doing something like you're calling the sum function, and this function sum function is returning the value. That value you're storing at final result. Okay, that is actually your agenda. So now what it is returning value. Okay, it is returning value. Now the concept of use callback has been revolved around the concept called function definition. Means caching the function definition. It means that for each and every render, the function definition is not the function is not going to recreate again and again. It will for if there is no dependency change, what will happen? If there is no dependency change, the function would be getting from cached. The function which you are getting is cached one, and if there is any dependency change, the function you're getting is new one created. Okay, now actually, now if you see this one, now the use callback is working with function definition. Now here the concept use memo will be worked on the value, and the same thing which what is use callback is doing, the use memo is will be doing the same thing. Here what is the actual agenda? Our actual agenda is something that to cache the memo is to memorize the value. I mean to cache the value, not the function. Remember, not the function. We are caching the value which is returned by the function. Okay, now understand the scenarios in real time. In real time, think of that there is a case where there is an expensive calculation is involved. Now let's think of that. We have I'll show the example. I have a project called Stadium Rover, right? In the Stadium Rover, inside that project, there is some large count of players coming every time. Suppose if you have sorting implemented for sorting implemented or filtering implemented for players. Now what it will do? It will calculate by iterating over the big data list. Something like if you see something, suppose take an example of sorting. Say take an example of sorting. Okay, take an example of sorting. What sorting will be done? Sorting will be doing something like sorting will be happening on array of list. Okay, array of items. Maybe array of items. Maybe 0 comma 1 comma something. You have 10,000. Something you have something 10,000 items. Now what it actually do? If it needs to sort the 10,000 items, it need to check each and every item, then it needs to perform the sorting on 10,000 items. This is something like expensive calculation. This expensive calculation. Suppose think of that in your component. If you have such type of expensive calculation functions like 4 functions, what would happen? Your component would be super slow. Your application would be super slow. If you have something expensive calculation, these expensive calculations are in number of four expensive calculation, then what will happen? Your application would be super slow. So in this case, we need to implement some React advanced techniques like use callback or use memo, and you occasionally see both use memo and use callback in combination. You will be seeing use callback and use memo in combination. That I'll explain you, no worries. But for now, you understand, when there is an expensive calculation, you definitely make use of the concept called use memo, and use memo will be working for this particular scenarios only. So when there is an expensive calculation, this value which is from expensive calculation is memoized. Memoized, it seems that what even memoized? Memoized is nothing but cached. Cached. Once the value is cached, Now same like use callback, use memo is also having same. Use memo is also having the same syntax. You will be having one function, then you'll be having dependencies. Okay, dependencies. Okay, dependencies. You will be having some dependencies. Okay, whenever this dependency is got changed, this function which you passed will be calling. We use memo will be calling this function, and it will get the result and stored here. And it will get the result and stored here. Okay, if that dependency not change, it will get the value which is already present, that is cached value, memoized value. So the basic concept behind the use memo is caching or memoizing the value, written value, not the function definition. Remember, I'm stressing the point. Use callback is used to memorize the function, but whereas use memo is used to memorize the value. Okay, that is the major key difference between use memo and use callback. So both the things are used on functions only. One is for used for function definition, one is used for function return value. And you remember, use callback is used for something like handling the function creation, something like if you have something called filter function defined on parent component. So now what happens means, inside that parent component, for every each and every render, you need to recreate the filter function again and again component rendered, you need to create the filter function again the filter function. How many times you'll create the filter function for each render? If you try to create a filter function, that would make your application super slow. So then you need to control the function creation and also re-renders that I showed you while we are discussing with use callback. Now we'll be discussing some concepts related to use memo and what is the issue, a live proof for issue, and understanding the issue with the code, and thereby we'll define a solution for this using use memo. Okay, now you understood, right? It caches the value produced from expensive function. So for all the expensive calculation, you need to use memo. So now next thing I will be showing, this is one real-time example which I prepared, but I don't want to show this one now. I will be showing first a component, a real-time, a real-time small scenario that explains the concept of use memo. Okay, now I'll go here. I'll try to, this is use callback, this is completed. Now I'll try to create one more function, and you can have all this one in a GitHub repo. I'll push all the code to the GitHub repo. You can get from there. Okay, I'll create a new terminal, and actually npm npm create white at the rate of latest. Okay, now this will create, I'll try to create use memo project. From there, I believe we almost covered around 5 hooks, and I'll quickly clear some small projects, small hooks that are more not used much, but better to know that one, and we'll end up the session. Use memo, use memo, React, JavaScript. Now cd use memo, npm install. Then it will take some time, just 2 more time. Then mean the time we can do, we can wait for 2 minutes. That will complete the creation of project. Once it gets completed, then we shall move and we shall continue with the discussion. Then once it gets completed, then we are good to go with the next concept. Okay, once we are done with use memo. So remember the concept. I'm stressing you the point. It is very much necessary to understand each and every hook which is there, built each and every built-in hook. Not that you need to learn and remember all those things, but at least you need to learn the few things which you can use for building the hooks. You can also build the custom hooks. For building that custom hooks, we need to know the minimum knowledge of how to use the hooks and what are the basic concepts of hooks, and how do you create a hook. Those things you need to for a minimum well, you need to understand what the actually it is. So in the series we have seen about use hook, use effect hook, and use context hook, and use ref hook, and also now use callback. Now we are discussing about use memo. And there are some more hooks which are present, like use reducer. So use reducer is a hook which is much similar to use state, but already I explained you the concept of React state management. There you have a concept called reducer, right? The same concept will be happening with reducer hook. There, what the use reducer hook is used to manage the state of a complex non-primitive types like arrays or object. Okay, we are not gonna discuss that that thing. We can easily simply refer the official documentation. That's very much pretty. It's a very much pretty straightforward one. No need to worry much about that one. How use state is working, the same manner that use reducer is working. So, use reducer will be working, and there are some more hooks which are into which are into the React recently. So you can find what all the hooks getting introduced on the React every day from the documentation. But for now, you need to everyone, even the interviewer would be asking you, testing you the concept of all the basic hooks which I am saying now. Okay, these are the concept which we have discussed. That concept, that the thing is required for attempting the interviews, and also in real time. This is enough. This is enough. If you want to extend more, you can find the hooks present in the documentation, and you can go ahead from there. Okay, let's come back to discussion of use memo. Now I'll run the npm run dev. This will run the server, and I'll just clear the app.jsx for, I mean, for better control of the component. Okay, I'll just want to control this component by removing this one. Okay, removed. That's fine. That's fine. Now you removed and you don't want this one. Done. App.css is required. Now what we will be doing here means, okay, now you have something const state variable. That's fine. And okay, now inside here I'll try to display the, I'll just explain with a simple example, not much complicated, not something like it's a big concept. But this concept is very vast concept. You need to understand. Even though I explained by taking the small example, when you goes into the real time, it's sort of like you, when you understand the core concept in real time or in real time application or something, like whenever you see the use memo hook somewhere else, you can easily grasp the idea. So the basic motive here is to grasp the idea how use memo is working. Okay, now you have something called h1 count, then a button to increment the count. Okay, now what happened, I just don't want to write here this one. I'll just move this one to some function called handle increment. Okay, control X. I'll just create a function. Okay, handle increment. Okay, handle increment. Done. Now I'll define a function here. Handle increment. Handle increment. Handle increment. That will, what it will do? It will simply update the count variable. Okay, done. This is done. This is done. I am done with now. Now what happened? Here the count variable. Now let's see this one, how it works. What? Why it's not? Why you are not able to see this one? Okay, now increment count. This is working fine. This is working. Okay, done. This is working as expected. Okay, fine. Now I shall go here and I'll do something to simulate the performance issue when you are not using the use memo. If you have some expensive calculation involved in your component, and if you are not trying to use memo, what would happen at that moment? I'll just try to show you that. So let's define another function, one more function called const expensive calculation. Just normal, it's a function, just one name, that's it. No worries about, no worries. You don't want to worry much about this one. Okay, now see, I just have this expensive calculation here. Now what happens? When without this one, without expensive, now you need to have something large one. Okay, now see, now what happens? Now here I want to show that calculated result. Okay, now let's see, result equal to expensive calculation. Okay, now I'm calling this function expensive calculation. Now this, you see, count into 2, count into 2. That's very much normal function with a normal calculation. Now you see, there will be nothing will be happening. Now see, when you go here, you see calculating printed. So I need to remove this React strict mode. I'm forgetting every time. So React strict mode should be there for development mode, and something like React strict mode, React strict mode would is helpful in making your component optimized, not an optimized, controllable. Something like you can avoid unnecessary error components going into errors and unnecessary memory leaks. You can this React strict mode will identify. Okay. Now this one I'll just refresh here. Now you see calculating. That's fine. That's fine. So what happened? This function got created. What here the function got created. That's why you are just seeing the calculating. Okay. Now what happened? Now when I click on this button, increment count. Now see, the result is being changed. See, it's very small. Anyway, it's very fast. See, you are seeing very fast. The calculating function is creating very fast, and it is very fast, super fast. You are seeing everything super fast. Okay, and the result you are getting is the result is from where the result is there. The result is from this expensive calculation, and you are getting very fastly this result. Okay, that's enough. That's enough. When you go here, and you want to involve some computation which lags actually. Okay, which lags. For that one, what you will be doing means I just do something like let temporary let us think as let result equal to 0. I have initialized one variable. Now what I will be doing means this calculating would be fine. That doesn't make sense. That is not a problem for me. For I'll write a loop here. See, I'll write a loop to simulate the user yeah, to simulate the issue when you are not using the call use memo. So now what you are doing, you just write something for I equal to 0, I less than or equal to 10,000, it's nearer to 1 million. Then what you are doing? You are doing something called result, result plus plus. Okay, result plus plus. Now what it does actually? Now see what it does actually. You would be seeing something called why this is a result is assigned but never used. Okay, I haven't used this one. What's this error? Let result I have declared here. And okay, then okay, I need to use okay, return result. That's fine. Return result. Okay. Now what I'm doing, I'm just initialized one result variable. Then what I do, okay, it started. Now you should not. This will make the component my system also slow sometimes because of this function. Now this is an expensive calculation which is involved in your component. Remember, this is an expensive calculation which is involved in your component. Now what it does, it initializes one variable called result, and it has a console log calculating. Then you have something called let I equal to 0, and it simulates I is less than or equal to 1 million. Then for every increment, it is incrementing the value. Then you're getting the result. So this function will simulate the issue of use memo. Now what happened? I'll go here. I'll just refresh the page. Refresh the page. Initially, see this. Observe this refresh button. Observe this refresh button. What it happens actually? Actually, my system is very slow, but still this one is making my system very much slow. I'll try to explain you the concept why it's taking much time. This is the reason if you initialize something like something expensive calculation, it all uses your resources, CPU resources, and it will make the component somewhat, see it calculating. It started calculating. It's still not rendered the UI. Still not rendered the UI. It's taking very much long time. Okay. For now, come on. It should get the value. It will take up all the resources of your CPU. It will take up all the resources when you do something like I'm saying you right. This is not the problem with this is the problem with everyone. When you do something like memory leaks, if you unintentionally, if you by knowing or not knowing, if you do some memory leaks in your application, that will bloat your system. You would be seeing some memes, right? Someone will be writing some code. Suddenly, a message will be coming that your PC ran into problem. Why that will be happening because of this memory leaks. Memory leaks. The memory will get leaked, and due to that, you would see the issues actually. See now result is see how much time it takes to print the result. Again it gone. Actually, I refreshed. Again it gone. Okay. Uh, it takes around 10, maybe something like instead of this one, I'll just reduce the counter, make it just for simulation purpose only, right? We don't want to do it very much greater than in a greater aspect, but I want you to understand the concept. Huh? That's enough. That's enough. Now see, you are even understanding now itself only. So it's taking my all CPU resources and it's calculating, and this particular thing is running still. This particular thing is running still. That is the reason why you are seeing the block in UI. UI is blocking actually. Come on, get soon, get soon. It's taking time, time, time. Let's see what is my CPU usage. My system got freezed. See, file is using around 74% of CPU, 70% of memory. Why it's lagging still? 38, 75% of memory, 35, 38% of CPU. See, efficiency. And it's been 70% of my CPU is consumed by the browser. By the browser itself, it's consuming my 70% of CPU. It's still taking time. Come on. Okay, I believe here. Now you're seeing 1,000, right? Now you're seeing 1,000. Okay. Now what happened? If I click on increment count, now what I am doing, I'm just clicking increment count. You're seeing one for immediately fine. If you change it to now, I'll be changing it to 10, 1 lakh. Okay, 10 lakh. Now see when what happens. This expensive calculation is being called here. And it's showing the output. Okay, and it's showing the output. Now what happens? Now if we go here. Now what happens? Now if I click on increment count, now see the rendering of number two. Now you clicked. It took some time. It took some gap actually. See, I will increase this count. Okay, I will increase this count. Now you see if you click on wait for updation of this result. Then if you click on, now it got hanged again. As I increase the value, it's getting hanged. So this sort of thing is memory leak. We in our terms, in our language, we'll be calling this as memory leak. Okay. Now, if you see here, when I click on increment count, I have clicked the increment count that, but this count has not been incremented. Still, it's taking some time to increment. It got freezed. So this is the main problem you need to address when you are developing the application. Remember, guys, this is the thing which you need to focus as a developer. You need to avoid the memory leaks. So this is one of the expensive calculation which I simulated now. This is one of the expensive calculation. So this calculation would take around some time. This when this is happening in a background, the UI would be getting lagged. The UI would be getting lagged. Actually, that is the reason. That is the reason why you need to focus on optimizing the component. If you optimize your component, you nowhere sees this type of errors. Okay. Now what happened? Let it complete. Let it complete. Meanwhile, I'll complete the theory. So to avoid this one, what you will be doing means you will be memoizing this expensive calculation function. What it does means when you try to memorize this expensive calculation function, what it does means it will for the first time it will calculate the value. Okay, then you will be passing the dependencies along with the function for use memo. So then again this expensive calculation would be triggering and would be calling at the moment when the dependency got changed. If there is no dependency change, this will be returning the old value only. This will be returning the old value only. Okay, this will be returning old value only. See, I it not even allowing to click the button. It got hanged. Okay, so this is, so you want to address this issue, what you need to do, you don't have other go to, you don't have other go to deal with this type of problems. When you have large expensive calculation, for the first time you trigger that calculation. Okay, you trigger that calculation, you store the value, you store the value in use memo. Then what happens next time again, if dependency got changed, then only you trigger the value. Unless then you don't trigger the value, you don't trigger the function, you don't call the function, and you don't get the new value. That's the only solution to be worked out in such type of scenarios. Okay, previously you had seen something called use callback. In use callback, what you said creating a function. Now what you're saying, calling a function. Now calling a function is being, because of this expensive calculation, we limit the calling of function, and we control the calling of function based on the dependencies. Okay, based on the dependency. Now see, I click increment count. Now see, it got console. Now you are seeing still 5. It will take some time to get 6. Now what is the problem here? It is waiting for completion of this complete count. For complete for loop completion, it's waiting. That is the reason you are not seeing the updated value to hand. See, my browser got freezed. You can see, you can feel it, right? My brother got freezed. Okay, to address this type of issues, what you will be doing means, you will be just using something like const memoized, memoized const memoized value equal to const memoized value equal to, you just pass this created value for use memo, and this function which is your which you are doing something like this function, you pass it to use memo. Then what you'll do, you just pass the value count. Okay, pass the value count. Now pass the value, maybe something like this one. You can assign this one to, for example, you can remove this one, num, maybe keep it as num, and you can have something called const num. This could be something like dynamic, any value. It could be any value, not only this value, it could be any value, and you can simply pass this num here. You can pass this num here. It means what you're doing, you are calculating this expensive, you're calling this expensive calculation when the num value got changed. Okay, and you're getting the result whenever this num value called. Now you can take this one memoized value, and you can replace this one, memoized value. Okay, that's all completed. Now your work is completed. Now what you did means, now what you did actually, you 100% you need to have this function called for the one time in a component render cycle. In a component render cycle, you need to have this. Okay, you need to have this function. You need to, sorry, I'm getting some messages in the background, that's why. Okay, you need to have this function called every time. You should not have this function called on every render. If you call this function on every render, what would happen? Let's think of that issue. Let's think of that issue. You have something called handle increment. If you haven't passed this use memo, what will happen? If you click on a handle increment, what will happen? This handle increment, this function would be recreating again, and this function would be calling again. And it waits for this completion of this completion of this whole process, for the first render, and second render same thing, and third render same thing, and fourth render same thing. So this will be something like a process where the rendering which the thing which you are doing is not that much of an efficient way. It's not an optimized way. So you need to make this calculation happening for particular reason. So here my reason is something like num change. Whenever the num change got, I need to calculate this expensive calculation. So that is the reason I'm just passing for use memo this expensive calculation and a dependency array called num. So if I did something like this, what happens means, you see, if I click, wait, for initial time, at the initial time, type memoized value is not a function. What is this? Okay, sorry, my bad. Okay, okay, I just made it right. Where is this? Now see, at the initial time it called a. Now see, when I increment count, it's happening very fastly. See, now it's not blocking. The updates are very quick because now this result is based on dependency. What is that? The core concept. The core concept behind use memo or use callback, the dependency. If the dependency got changed, if you're changing this num value based on any dynamicality, then what happens? Again, this function would be calling for each and every time this number got changed. But here on handle increment, you're setting the count. Even though you're setting the count and you're re-rendering the component, this particular function is not calling again. It's not calling again, and it's not even returning the value. So this is the beauty of use memo. This use memo is particularly used to return the memoized value instead of new value every time when you use for expensive calculation. So remember this thing. This thing you need to very much this you must be very much careful about this one. Very much careful about this one. Okay. Now I have something called. I'll be showing one more scenario. Some in use callback you had seen something like render creating a function controller, controlling the creating functions, and also something rendering. Rendering the controlling the re-renders of child component, right? Now think of, right, you have something called child component again here. You have a child component. I'll be creating that child component. Now just a small concept. This I'll be ending in soon ASAP, no problem. RAFCE. Okay. Now what happens here from app.jsx? I will remove this expensive calculation because I don't want this expensive calculation that makes my function blotted, my system blotted. Okay. Now you have something called I don't want to have this one. I shall remove this one, and you have only count now. Only you have count now. Okay. Along with this, I will be creating one more variable called one more variable const const uname. I mean, it's sort of like a username. Okay, I'll just name it as set uname. Okay, set uname. That's fine. Then what happens? Then use state maybe something like my name Satish. Okay, that's fine. I just created username. Okay, now what happens means, now here initial state is this one. Now what happens? Const I will be creating one more user, a user called, and in this user I'll be creating one object name. Now why I am giving this example is, it's very much interested to learn this one. Actually, see what I will be doing means, here you have something called uname. Uname is a state variable. That uname is assigning for an object. You created an object called user. Inside that user object, you have something called name property. For that name property, you are providing a value called uname. Okay. Now what is your uname? It's a property value inside the user object. Ultimately, this is a non-primitive data type. So now you are working with non-primitive data types. When you are working with non-primitive data types, for each and every render, what will happen? For each and every render, what will happen means, it will create new memory location. Remember, it will create new memory location. For each render, it will create a new memory location for each render. So that means, so the object which you created at the first render is not equal to second render object. See what it means? It means this is something like inside the first render, inside the first render, what you did? You create one object. It creates one object, something called user object. You created one user object. Okay, that's fine. This see then in second render, you again create one more user object. It again creates one more user object. Are the both same? Even this has same value. These both are not same because first render. Sorry, I'll write first render is not equal to second render. I already showed you while explaining the use ref. The same concept would be applicable here. So because this user will be creating in the location, for example, this is object at obj 100. This object would be creating at different location. Now both reference to different locations, different, both references are different. That is the reason you are seeing for each and every render a new object is being created. Now what I'm doing, I will be sending this user object to child component. Now what I'll see, I'll have something called child component here placed. Child component, I just get this one, and I'll pass this user. What I'll do, I'll pass this user complete user object to whom? I'll pass this complete user object to complete user object to child component. Now child component should able to receive this one. So now the child component is I'm just receiving this component. Okay, I'm receiving this prop. I'm just receiving the prop, and here inside this one I will be just destructuring it, and I'll be getting the value of user dot name. That's fine. That's up. That's all done. That's now you are good to go. Now you're good to go. User dot name and user. So now what happens inside here you have something called increment count button, and also something called I will be creating one more button called this button is something like which sets the name, sets the uname, something like you can pass okay, don't worry. This is very small concept, very small concept, and you don't want to I don't want to confuse more. It is very simple concept. When you focus, it is very simple concept. If you are not focusing, that will be taking you some time to understand. Now, what I did something very similar thing. So I explained you this one why this is happening because it's a non-primitive object. Non-primitive. I just have two state variables. One state variable is for triggering the re-renders. Okay, re-renders, triggering the just to trigger the re-renders to observe the behavior of use memo. Okay, and you have something of something a state variable that holds the name. Okay, and this name variable is passed to object. I have created one object to demonstrate the rendering issue of this use memo. Now you have an object that user object is passed to child component. Okay, now what have yeah, along with that you have a count, along with that you have a two buttons. One is increment count, another is increment set name. Okay, set username. Okay, set username. Okay, done. You're done, you're good to go with. Now when you go here, actually you're destructuring this one is all works out, it's all well. Now you go here and you'll see first primarily you're seeing something like name and also count equal to 0. Now actually what happens? Now actually what happens? You could see here. I am just depending on this what is this prop? This prop is something like user. This prop is something like user. What I'm doing here means I will be just having some console log here just to demonstrate the how this child component is behaving. Okay, child component, I just gives child component. Now see, I'm observing the component prop is user. Okay, this prop is getting from where? It is getting from parent component. Now you have two buttons to trigger the re-renders. Okay, now see here, I'll just refresh here and I'll just go here and click on increment count. So the child comp is rendering. So once again, I need to remove this strict mode. It doesn't have the strict mode. What's the issue then? Okay. Am I seeing the correct folder? Yeah, it's correct. Might be correct. Okay. Anyhow, no problem. Just observe this one. Child component re-render. Yeah, this correct. Child component rendering. See, it's rendering because actually child component is rendering because when you're clicking on increment count. So where is the count? Here is the count, and count variable is here. Completely this is restricting to, this is associated with only parent component. And child component has user. It is something that a user an object which is created on parent. But this is not being, this is only the thing which is being sent to the, for whom? For whom? For whom? For child. It is the const user is something that which is being sent to the child component. You are nowhere sending the count component, and you are nowhere associated with the handle increment or count. This child component is nowhere associated with count and handle increment. But still, if you click on increment count, what happening? It's happening. Set username. Okay. Okay, sorry. Set username. This should not be something like this. If you make something like this, it will constantly having only one thing. Maybe I'll do one thing. Username plus one. Username plus one. That will dynamically update. Okay. Okay, now see, now what happens? Child component set username, child component running. See, this is happening. This is going on. Actually, this is actually just simulated. Just I simulated for checking the children component is rendering or not correctly. Whenever set username, you are what are you doing? You are updating the username. Uname. So uname got updated here. That uname is passing to this object. you're setting uname. Setting uname means what it does. Setting uname means nothing but you are making the component to re-render. So once you re-render, a person object, a new person object would be creating. So and it sees and this component will see the change in user object, change in user object, because this is create for each and every render. It will create in a new memory location. That is the reason it will change. It will see the change. It will see the change in user object for every render. Now what happens for updated value? You should definitely visit. It should definitely observe the prop and it should be able to re-render. Okay, that's fine. That's fine. Now what happens? Now I click on set username. It sets the new name, and new name would be triggering the re-render of the component. That triggering of the re-render that re-render component, once it got re-rendered, what it happens means this will create a new object. That object is being observed by child, and as it got re-rendered, as it got updated, this particular object is got updated. That is the way you are seeing the updated value on username, user.name. Now along with this, if you do something like, if you click on increment count, what is happening? Actually, you are not even passing child component, not even observing any of the user count and any of the handle increment, but still you could able to see the child component rendering when you click on increment count. Actually, why this is happening? Why this is happening? And you have something called React.memo, right? Why you can use React.memo. React.memo, what it will does, if we have something called React.memo can be used. You might we already see the concept of React memo, right? React memo, what it does actually, it constantly observe the prop variable. If prop variable got changed, then it will re-render the component. That is the component. That is the concept of React memo. Now you have applied the React memo. It's okay. Now it is observing what it is doing. It is observing the user object. That's the right. Your React memo is observing the user object. Now what happened? If I click on set username, this child component is re-rendering. That's fine. When you click on increment count, again it's re-rendering. Why? It is observing, right? React.memo is observing the concept, observing the user object. It's not it's a, so whenever only change in user, then only the re-rendering would be happening. But why it is re-rendering? For even when you click on increment count, what happens? Let me say you that one. Actually, this is a primitive object, non-primitive data type. As I said, that non-primitive data type would be storing in different location for each render. Okay, for the first render, the function would be something like object 100, second render object 200. Now what is this object? Actually, this is user object. That means that this particular component is seeing user object in a different way, for each render. Now this user object is being observed by who? Child. So for each and every render, what happens? Even though you have provided React.memo, still it sees the different value only, right, for each render. That is the reason why it is rendering the current re-rendering the re-rendering it sees when it sees when a component is being re-rendered. When you click on increment count button, the component re-rendered and a new object would be creating. And that because of the new object, as child assumes that user object got changed. That is the reason it is re-triggering again, re-rendering the child component. So to prevent this type of issues, we need to bring a concept called UseMemo. So where do we bring a concept called UseMemo? So now you have utilized React.memo and also use call here. Particularly in parent component, you need to memorize the value. What value you need to memorize. So for this one, you just go here. Instead of doing something like this, okay, you just simply do something called const. Okay, I'll write it up. No worries, just wait. I'll write it const user memo. See, okay, I just don't use this one. Don't use AI. For better understanding, use memo will act up two parameters. One parameter is called a function. Another parameter is dependency. That you understood, right? Inside this one, particularly inside this function, what I'll do means I will return an object. What I return an object? I'll return an object name equal to uname. Now here I'll be passing inside this. I'll be passing what I'm passing. I'll be passing username. See, uname, something like uname. I'll be passing uname. So now what it does means I will explain you. Now user object, whenever there is an user object change, this user will be particularly recalculated. I mean recalculated, or this value of user, the username inside the user object will be recalculated when there is actual change in uname. When there is an actual change in uname, then only this user object, this user will be recalculating the recalculating the name. So that is this function. This particular function holds the object which is really which is responsible for updating the name. And here dependency you passed is username. Now you go and check here. Now if you go and check here, what happens means I'll just reclear. Now see, when you click on set username, you'll see child components rendering, because this name is uname is being passed as a dependency and it's constantly changing. Now when you click on count, its count is being changed, but there is no re-renders happening for child component. How it got controlled? And you have utilized the concept of React.memo that control that observe the user. Now user is being created only when there is change in uname. Okay. Now React.memo, what it does, it observes the user. As it observes the user, it will just sees the change in user when there is change in actual uname. So actual uname will be when it will get changed. When you click on set username, then only child component would be actually this user new object would be created, or else it will be pointing to the old memory reference. That old memory reference would be passed to child component, as there is no change in previous value. That is the reason you could not able to see the re-renders again and again. Okay, so you need to make sure that UseMemo is used perfectly whenever it required. So, and you need to very much be careful about using of UseMemo and using of UseCallback. Okay, it's simple. It looks very simple, but in terms of understanding, in terms of making this possible, you need to very much clear about this one. Okay, so this is all about UseCallback and UseMemo. So this is one of the best thing which we have for controlling the React performance optimizations. And I already covered the React.memo also. Basically, in next session we will be covering custom hook and higher order components, and React controlled components and uncontrolled components, and some sort of small concept in next session. After that session, we will be covering React router. Then we will be going to actual project, and we'll end up the React batch. So maybe 4 or 5 sessions would be required to complete this batch. So I'm aiming to complete this batch on or before some Monday. So that's my actual target. So you just please support. What you need to do means I just give the so it's not possible to explain each and so I'm just giving my level best to explain the architecture behind what's happening. I'll just give in the same way only. But you need to understand the concept by seeing 1 or 2 times, more than 2 times video, and you need to you need to understand, you need to make the complex concepts clear by yourself. And if you are stuck anywhere, you just ask me, because I am extensively giving you the architecture concept behind the concept what actually happening. So you can see no one will no some you'll be seeing these concepts in all over the YouTube. It's very much prettier. You can find, but it's the difference between is something that when you understand the architecture, it is also fine. Those concepts also fine. Okay, you need to understand the architecture behind what's happening. Okay, so just I believe I try to give my level best to make you understand about the hooks. So this is all the built-in hooks which we have covered. So tomorrow we'll be covering the custom hook concept. That's a very simple concept. Then we'll be moving to some few concepts. After that concept, we'll be moving to the understanding the router. From router, we'll be moving to understanding the actual project. Once we complete the project, the React batch would be ended. Okay, that's all for this session. Maybe tomorrow we shall meet in new session.